So the first topic, can boost asio-based code be adapted to use seastar reactor? I'm not sure who added that. Do we have anybody leading this?
So at a super high level, I believe the notion here is that there's a bunch of code in Ceph already that relies on boost ASIO. So the question is, how easy would it be to adapt that code to run within Seastar? Can we, for instance, wrap it and just run it directly in the reactor with appropriate wrappers for wiring up the callbacks? I think this is just investigation work that needs to be done for librd to start with. I think that's the important first case. I haven't myself looked into this yet, though, but that's my understanding of the ask.
Yeah, I think the new radar stuff all uses asio, boost asio. Maybe Josh, did you add this by any chance?
I didn't add it myself,
from
but
Sage.
I think
okay, was it Sage? Okay, it was Sage. Okay.
Well, I have a little more context about this as well. It was actually an idea Jason had. He had already rewritten librd to use the NeoRados interface, which is based on Boost ASIO. And his thinking was that it might be possible to template out the implementation-specific pieces of futures and slash coroutines slash reactor, and leave the messenger with only, like the Crimson messenger, for example, with only the protocol logic. So then you A, get a unit test for the protocol, and B, not have to have a separate implementation of Crimson messenger versus async messenger. But that was more of the idea phase. So I think, like Sam was saying, it needs to be investigated to see how feasible that is.
Likely with some sort of initial prototype, proving out what the code would look like.
Mm-hmm.
I don't know that there's much less to discuss here, unless someone who's deeply familiar with both Boost ASIO and Seastar would care to comment. Right. Like not so much. Sure what RWL replication info is.
Topic was from Chang. You're there?
Hi. Yes, George, I'm online. Is it time for me to talk about the RWL replication work?
Yeah. Go ahead.
Okay. I'm a software engineer from Intel working on Ceph, and my peer Jinpeng is also online today. That we will talk about the design of the replica daemon and the replica monitor. Is it okay for me to show the slides?
Yes, please.
Sure.
Oh, okay. Can you see my screen now?
Yep.
Okay. And it's unloading. And previously, I think that Lisa has talked about the RWL replication work, and today that I and Jinpeng that will focus on how to design the replica daemon and the replica monitor to manage the replication information. And for the RWL work, previously that we have finished the design of the single copy for the NVDIMM and SSD write back cache, and these features has been merged. And for the next step that we are going to do replica the data across the NVDIMM over the RDMA protocol. And for the first part is that we focus on how to manage the client cache information to do the further replication work. And for the other part currently that we haven't started yet. And today that on this slide, it is the basic framework about that how we design the replica daemon and the replica monitor. Firstly, is that on the left screen of the slide, and that the replica daemon we report the replica daemon information to the replica monitor. This information includes that the RDMA's IP address and the port that is used to listen for the coming connection. And the other information also includes that the free size of the NVDIMM. And after that, the replica monitor receives this information, that it will store it into the replica daemon map, and it will also go through the Paxos service to keep consensus of the replica daemon map information across all the replica monitors. And for the client side, on the right screen of the slide, that for the client, it will use the replica. It will use the get replica daemon map message to request the replica monitor to choose the proper replica daemon and aggregate the information, and then that the replica monitor will feedback the replica daemon map information to the librd, and then that the librd will start the connection to the replica daemon for the replica work. And currently that we have write the code to request further comment from the community. And on this slide that we show that the basic framework about the replica daemon and the replica monitor, but we also have the we also have a basic document to show the to show that what metadata are included in the replica daemon, and how that because that we also have defined 3 kinds of messages, and we also have designed these 3 message classes to be used between the replica daemon and the replica monitor, and also include that how the librd send the request to the replica monitor, and then that the replica monitor will use another message to feedback the information to the librd. And I will open the framework design document. Okay, and on this screen, and for the replica daemon information, it includes that the daemon ID, and it also includes the RDMA's port and the RDM's IP address, and there's another member field is to store the free size. And for the replica map, because that the replica map will be stored in the replica monitor, and it includes all the replica daemon information. So that currently that we only use STL vector to store all the replica daemon information. And for the client side, that when the librd when the librd send the request to the replica monitor, it will include the information that what's the number of replication. Here we define the field replicas, and it will also include that what's the requested replica size to the replica monitor. And for these three kind of metadata information, that we also have defined the proper messages to be used between the replica daemon and the replica monitor, and also between the librd. And for the when the replica daemon reports the information, report the replica daemon information to the replica monitor, it will use the message replica daemon blink message, and this message will include the replica daemon information. And for the client side, just for the librd, it need to send the get replica daemon map information to the replica monitor, and then that the replica monitor will choose the proper replica daemon and aggregate all the information into another replica map, and it will send the replica daemon map information back to the librd. And these are the three kind of metadata and the corresponding messages. And in the end of and in the bottom of this screen, this is what I have showed on the slides just now. That here that we use the blink message to report the daemon information to the replica monitor, and then that the librd request the replica map through this message, and then the replica monitor feedback the information to the librd through the replica daemon map message. And currently that we have sent the email to the community to look for some feedback, and so that could you Josh and others, could you give us some suggestions about this design framework?
Why does this need to be in the monitor?
Do you mean that the replica daemon map information, why it is in the replica monitor, right?
I mean, why is the monitor involved here at all?
Sorry?
So there are other ways to maintain persistent mappings in Rados that don't involve modifying the monitor. RGW, for instance, maintains information about caches in using watch notify in Rados. RBD does the same thing. Why does this need to use a new Paxos service?
Currently, that for this kind of information that we have, that I have looked through about the OSD monitor, and because that most of the Paxos service are included in the replica monitor, so that I add another replica monitor which is inherited from the Paxos service. Yeah.
Yeah, I don't like that. I don't think this should be in the monitor at all. I think you should be able to achieve roughly the same effect with primitive Rados operations and watch notify. I don't think you need to modify the monitor at all.
For the currently,
all you're doing here is publishing a mapping, right?
Yeah.
So why not put that in regular Rados objects?
Rados. For the design about that for the design of the Rados or the RGW currently that I haven't looked through them yet because that I just take some other Paxos service and then that I add. Yeah.
This is a huge maintenance burden, like massive. If you can do this on top of the LibRados interface, it'll be much easier to merge. This is almost impossible to merge.
The problem is for this kind of metadata. Do you mean that we need to manage it on the above layer of LibRados?
I'm saying Rados itself, like the interface, the library interface, offers primitives for performing operations on regular Rados objects with the ability to create locking and notify mechanisms. I don't think you need to embed this in the monitor's Paxos service. It'll be less code to write, it will work better, and it'll scale better if you implement this in Rados.
So
that is on top of LibRados.
So for this, is there some design document about that how to implement this kind of design based on the LibRados?
All I see here is an RBD name to set of daemon mappings. That's the RBD. That's how you locate the replicas for an RBD, right? Secondly, there's a registry of available replica daemons. You could put each of those two things in a Rados object with some kind of watch notify to maintain authoritative ownership and ensure atomic mutation. LibRBD already gives you ownership of a particular RBD object. So that part's easy. You simply ensure that only that client is allowed to modify that mapping. In fact, you can embed it directly into the RBD's metadata itself. I'm not really sure why you need that to go into the monitor in the first place. The second part you can maintain with just a registry, just an object containing a binary representation or whatever, an OMAP entry for each one of these daemons with a last seen alive time if you're trying to detect failure. I mean,
but the problem is that we need a center to gather all the information about the replica daemon, and then
yes, that will be an object with a single well-known name. Right? You already have a cluster that you agree on, so all you need to do is write an object with a well-known name, or a family of well-known names. A lot of ways to do it. I suggest that you study the way libRBD manages ownership of the RBD head object and the way RGW manages its cache semantics. If you ask on the mailing list, people may be able to point you at documentation for them.
I think the RBD mirror daemon also does something similar with managing which daemons are replicating which images.
So bluntly, there have been a lot of different projects that have needed to do something like this, and the solution is that Rados itself gained features to enable this. Adding this to the monitor would be an extreme amount of extra overhead. And we'd have to very carefully review it. We'd have to very carefully evaluate its performance properties, how much you're storing, how frequently it's updated. Worse, if it's poorly implemented or there are bugs in it, you could crash the monitor, which makes the entire cluster unavailable. So modifying the monitor is a big thing. So before we consider that, you should probably prove to us that it's necessary in the first place.
Yes, today that we are talking about that whether this way is the proper method.
Yeah.
Yeah.
I think we also need to go back and consider why we're trying to do client-side replication from cache to cache at all. I think when we had discussed this previously at CDM, it started turning into almost implementing an entire OSD on the client side. And at that point, it seemed like it might be more beneficial to implement this kind of RTMA replication interface at the OSD side and run the OSD on in front of these caches instead.
Actually, if I'm understanding this architecture correctly, there wouldn't be anything stopping you from running these replica daemons on the OSDs themselves. They'd be two different daemons, but they'd be physically located on the same place. You just partition the NVMe, which is not awful. It's not my preferred solution, but it's an interesting intermediate implementation that wouldn't require drastic changes to Rados. That's why I was asking, for instance, is it actually necessary that the libRBD instance have a local replica daemon? Does this system require that? I would recommend to you that you do not make it require that to enable the possibility that all of the replica daemons are actually remote.
Okay.
Do you see what I mean?
Thanks for your suggestion, and could you reply that the message, the email that I sent to the community? Hello?
Sure. I'll just find it.
Okay, thank you. And for the for what you just what you said just now, that I will talk with my peer Jimpen. Okay, thanks. Okay, that's all.
All right, what's the next topic here? Like the multi-core support in Crimson or M2N mapping?
Yeah. Do we have anyone here who wants to? I can talk about the broad strokes. There's a document linked here, which I think contains sort of an in-progress conversation. I think at a super high level, there's a lot going on here. We want to be able to run Crimson on multiple cores. I'm just going to begin with the assumption that it doesn't make sense to run one process core. Just flat out, it doesn't. So coarsely, we have 3 different resources we need to deal with. They're incoming connections from clients, which will come in on whatever port handles the message. There are state bundles for each PG. These will be the PG class objects, if you will. And then there will be the back-end, let's go with Seastore implementations. These numbers may all be the same, in which case a single message would be handled in the same core all the way through, or they may be different, depending on details of networking setup, core arrangements on the device, or amount of parallelism permitted by the device. So the other reason we don't want to just assume that messages will come in on the correct core is that old clients will be unable to, and for backwards compatibility reasons, we must support that feature anyway. So the short-term goal, I think, is to implement that middle piece where the PGs are allowed to be on multiple cores. We create multiple Seastar, what do you call it? Whatever their thing for we permit multiple reactors and we create a partition service or whatever that spreads the PG across them. And then we allow the messenger to farm out messages to the relevant core based on which PG. I think that's the first piece of work. After that, there's work to be done in getting Seastore to partition up a disk among a number of discrete cores, but that's a little bit further out. Radek, it looked like you had something to say.
Yep, I got a question actually. Question slash proposal. Maybe we can simpler way. I was thinking about actually turning that. What is currently Crimson? What is currently named as Crimson dash OSD
Radek, I don't think we can hear you. You're breaking up. Your audio is just breaking up.
Let's my idea. I have to research LT. My network, is broken, so I'm running on a backup. I'm afraid it won't be better.
I think
That
we
sounds
can hear
better
you
now.
better after you turned your video off.
Okay. So I'm curious whether we really need to pass connections, pass messages across the cores. I understood that we are thinking about we need to implement, we need to bring more, let's say, front end processing, OSD's front end processing capabilities to saturate, to be able to saturate fast devices. One core is not enough. We need to have more front-end processing power to saturate fast device. But I'm not sure we need to, in order to do that, we need to shard across PG. Maybe we don't need to worry about sharing resources at all, and just have multiple OSDs in the same process, in the same address space, sharing just single instance of
Why is this?
Of object star.
Like, they share the same failure domain. It means that you can no longer move data from one to the other easily. I'm not sold that that's simpler, Radek.
But actually, in Crash, our domain failure is host. So no huge difference here, I believe.
No, it's not that. It's that every OSD requires metadata in the monitor. So you have a
yes. Of course, and this I'm not saying that it's extremely straightforward. It would require some extension like
no, it's not that. It's that's wasteful. We multiply the amount of metadata the monitors need to track for OSDs that have to always fail at the same time. That's wasteful.
It's wasteful, but I'm not sure whether we need to fight with that. I still keep in mind
monitors do actually have OSD scaling problems.
Okay, that's something new. I was unaware about. I kept in my mind a picture where literally the 10,000 OSD cluster testing. I assumed we have a lot of infrastructure capacity. I mean, processing power on monitors.
But they don't scale up. They can only ever be as fast as a single monitor, right?
Right. Okay.
Like, they don't scale out. Adding more monitors doesn't make the monitors faster. So baking in a bottleneck like that doesn't seem like a good idea.
Okay, but still, if this happens in production, then we could tackle just in time. Not sure whether
the other problem is that it restricts device usage. So if, let's say we have an NVMe device with, let's say, a terabyte or 4 terabytes, whatever, of space, and we need to use 64 cores to saturate it, right? That means we have to divide up that 4 terabytes of disk into 64 different disks. Just based on a uniform random assignment of objects to those 64 different OSDs, we're going to get a severe space wastage problem from the smaller or less used OSDs in that group, sitting on space that's allocated, but that they can't actually make use of. If they were all one big bucket, we'd get much better disk utilization. I mean, it just doesn't seem plausible.
Okay, need to think about that. I don't have an answer just for now. I will rethink, and we could think about that.
We don't need to make things perfect for Quincy either. What's kind of the simplest way we could get multiple cores running?
Well, the simplest way is what Radek is describing. We set things up so it just run multiple OSDs, whatever. I don't like. There's planning for Quincy, and then there's deciding what to do next. I think this is an important thing to do next. It's not that it needs to be there for production user, but it's important. Like, if I were placing resources, this is one of the places I would put them.
And actually, the implementation related things was I think I wanted to ask during this meeting. I understood that Chunmei has started working on the end-to-end mapping. Is this assigned already, or it will be divided?
Like I said, this isn't a single feature. This is a collection of improvements that will need to be made. So no one's going to work on end-to-end mapping. Someone's going to work on modifying crimsons so that PGs get split up among several shards. That's probably the first step. There's work to be done in Seastore rather, that I'll probably work on. And then there's work to do in the messenger, both in allowing it to run on multiple cores and advertise multiple ports, and modifying the Rados protocol itself to allow clients to correct one. So there are a lot of independent projects here.
Yep, and I think that Sichuan has already is already doing similar stuff for Seastore. I saw a PR from him about spanning multiple cores in more efficient way. And this leads me to another question. Have we considered to implement the sharding with, let's say, object store adapter? Is it even possible?
I'm not really worried about it. That's already running in its own process, in its own threads. So it'll scale independently, and any shard that needs to do I/O simply sends it to the common queue. We can be clever about improving parallelism there by partitioning the queue, but I'm just not worried about it. It's not a big deal. It'll be much more relevant for Seastore. You're talking about Alien Store, right?
No, sorry, Seastore.
That's the in-memory one. I don't really care about that, to be honest.
It's for testing, basically.
Sure.
It sounds like a memory store could be like trivially shardable, just by creating multiple of them as well.
You just create one per PG shard. You're not going to shut the OSD down and back and turn it back on, so it doesn't really matter if the mapping is persistent and done correctly, even. It's not a huge deal, I don't think. Do you see what I mean, Radek?
Yep. Okay, we got Keith.
I have some questions. How do we decouple the work of M2N messenger and M2N OSD? For example, how does messenger know which core to send?
You'll have to write some code to make it so that there's a cross-core service that exposes a PG to reactor mapping. So you look at the message, you do the OSD map stuff you need to do to resolve it to a PG, and then you look up at that cross-core mapping.
But that's
very
OSD
much like how
map.
classic OSD does it, actually.
The messages actually contain the PG they're targeted for directly now.
That's even true for client messages now?
Yeah.
Even easier. Cool.
The
The only tricky part is if the PG doesn't exist yet. But again, you can have a look at how classic OSD does it. It'll be similar, but with hopefully less horrific code.
So
that is, look at the classic OSD fast dispatch system is basically what we're implementing here, but with better libraries. So like at a super high level, the messenger receives a message. It looks at the metadata in the message that tells it which PG it's supposed to be handled by. It looks up in a cross-core service, where is this PG? What reactor? It then uses the seastar primitive to schedule a future on that core that kicks off the handling process. That cross-core service to expose the location of the PG is yet to be written. That's a bit of work.
I'm wondering, is that part related to OSD? So messenger will deliver the message directly to the same core, the same.
No, that isn't necessarily true. That's what I'm saying. That isn't necessarily true. Once we've fully implemented all of the protocol work to inform clients of which port is mapped on which core and which PGs are on which core, yeah, that'll mostly be true. But even then, the client, we may choose to, until we choose to do that work, the message will come in on whatever messenger it comes in on, and the messenger will need to look up which core it's going to. There are a lot of reasons to support that pathway, other than, including, very importantly, backwards compatibility, but also because this way we can do this part before we do all of the Rados modification work, which will be a lot of work. So don't assume that it comes in on the right core.
No. I mean the OSD map look up to evaluate which message belongs to which PG. I think.
That may not be necessary. Josh is telling me that these days...
not being necessary in the messenger side. Maybe it can be part of OSD because OSD has most.
No, it's not necessary at all. It's not necessary at all. The OSDs all know, or the messages now all contain the actual resolved PG ID of the PG they're supposed to go to. So all the messenger has to do is look at that part of the message, figure out where it's supposed to go, and then look it up in the map. Not the OSD map, mind you. That's a whole separate thing. That's a reserved word and stuff. Sorry if the word OSD map. I meant the OSD service inside of Crimson that maps a placement group to a core, wherever we choose to call it. PG core mapping.
Where is it? Could you point
doesn't exist yet.
Out in the classic.
Oh, in classic OSD.
So in classic OSD, the fast dispatch immediately queues the message into the appropriate shard in the sharded work queue based on the PG that the message references, and then if that PG doesn't exist or is split or is being merged or something, when it gets dequeued, the classic OSD notices that this PG needs to wait for some reason, maybe for the split to finish, or a new OSD map to be processed by the PG, and puts that operation on a wait list. So essentially, the more complex OSD map handling is done at the OSD layer, not the messenger layer. It's deferred.
Yes. So why Crimson can be simpler, not to wait for some preconditions before dispatching messages to another core?
The only complicated piece is if there is no entry for the PG. That's the only one you have to worry about. If there is no entry, this service is simply going to provide a waiting list. That's it.
there will be some design notification to PG, which PG
So
to
the case where the
return
PG
to.
doesn't exist is the case where the client, we got an OSD map that moved the location of a placement group. The client immediately sent an IO to it before replication backfill, all that crap had actually happened. So we're essentially waiting on a notify to happen to cause the PG to come into existence.
So do you mean OSD map service will be embedded in Messenger?
No. Again, all the messenger will do is it will check the current cross-core mapping from PG to reactor. If the PG is there, it just immediately queues it on the relevant reactor. If it's not there, it sticks it on a waiting list for that core or for that PG and returns. That's it. When the PG is created, the reactor will go, oh, I have this PG now. It'll claim that queue and it'll move on with its life. There will be some subtlety in exactly how those operations happen just to ensure correct sequencing, but very little of it will happen on the messenger side.
So you mean if we got the PG ID from the message, we immediately know which core it belongs, right?
Well, we know which PG it belongs to, and then the OSD itself has in-memory state that is available to the messenger to tell it which reactor it's on.
So OSD will expose some interface
to the messenger. Yeah.
To tell.
Yeah. That's right.
It belongs to which core. And
that's probably one of the early things to implement.
It sounds like it could always be providing a queue to the messenger to put the message in, and it would either be the waiting list queue, the PG doesn't exist, or the correct queue for the relevant core.
If you're worried about the memory sequencing problem, there are techniques for getting around that. So these mappings will have some monotonicity properties that let us do RCU tricks. So likely what's really happening under the hood is there's a published pointer to a current consistent mapping from PG to reactor. And any messenger wishing to do a read from these things does so without barriers. It's just that it may be the case that they're reading a slightly out-of-date map, in which case, if they don't find the PG, there will be a slightly slower error path. But in the common case, they're just doing a barrier-free read to a well-known bit of in-memory state. It's synchronous in the sense that, yes, you're doing a memory read, but it's not synchronous in the sense that you're actually waiting for another core. Does that make sense?
Yep, there shouldn't be any on hot path. It shouldn't be any penalty, I believe.
No, there shouldn't.
From cache coherence,
we will probably go through more than one version of this service, but yeah, in general, there's no reason to expect there to be a penalty on the fast path. We'll just do the right thing.
Yep, but if I understood correctly, we would need at least without initially, without the extension to Redis protocol, we would need to somehow pass data between cores.
Again, we have to support that no matter what.
Yeah. Yeah, but it will be a bit complex because we need to implement. We cannot even after finding the proper reactor for handling traffic to particular PG. When we are responding, we will need to. We cannot directly send.
No, that's correct. The message will have enough state to find the original messenger. That's fine.
So this is another. Yes, it's fine. It's just another piece to implement.
Yeah.
Well, I'm perfectly fine with that. I would love just to ensure that the assumption that we really need to worry about the OSD map entries, the infrastructure traffic, whether it's correct.
Yeah, I think we do. For one thing, again, we need. Yeah, I'm pretty confident that we do. I don't think there's any realistic possibility that we can get away with an assumption that we'll have one messenger per.
Maybe 2 years ago there was a discussion on Ceph Devel we were iterating over that, and I buried in my mind that we have plenty of resources there. Maybe because maybe I'm just under the assumption.
In the monitor? No, the monitors are a
Yes,
fundamental bottleneck and stuff. They're the fundamental bottleneck and stuff.
I imagined I was thinking about the 10,000s OSD in cluster testing.
Yeah, I mean, we did this. I mean, Sage worked with oh god, CERN. There we go. With their extremely large cluster, and they're constantly hitting monitor scaling problems.
Okay, yeah. If so, then I am afraid there will be no other viable option than initially do the PG sharding and then make an extension to the protocol.
But I mean, the reason why I'm just not bothered about this is there are so many other reasons we don't want to have to run one OSD per core. It's just there are really a lot of reasons not to do that. So.
Okay, I agree. It's far from being elegant, but it's damn stupid.
Sorry?
Well, I believe it's the one OSD per core. It's very, very elegant.
Well, it's what we have now. We can do that. That testing we can do now.
No. Different thing. Sharding by OSD
is what?
The situation where you are sharing solely single object server instance.
No. I mean, I get it. What's the benefit of it?
Just simplicity. No need to worry about protocol extension at all. No worry about
also not worried about the
passing about.
It's not very complicated. This protocol extension isn't very complicated. Like, yeah. I get that this is simpler, and what I'm saying is we already have this version. Like, that's why we did this version first. Like, we can right now simply run one Crimson OSD per core if you just partition up the disk. We can already do that. And it may well be worth modifying Ceph ADM to do that for us in the short term.
But at the price of putting extra burden on deployment engineers and deployment tooling, it moves the complexity somewhere else.
As opposed to, are you saying you'd put all of the OSDs in the same process?
Yeah.
That seems really bad. Because if you crash one of them due to a memory corruption or something, it crashes all of them. That's real bad. If you're going to have more than one OSD, you should at least use multiple processes. It's way simpler.
Okay, you can have multiple OSDs, sharing just the object server instance.
Not really.
With memory, with some kind of shared memory. Not entire address space, just a region.
Then you're giving back. Yeah, this doesn't make sense. At that point, you're giving back the complexity you gained by moving it.
And you still have certain pieces of memory. Yep.
OSDs, you also have to pay the cost of dealing with cross-core communication for talking to the object store instance. So
yeah,
I don't think that design is worth considering.
Me too.
Anywho.
I have a second question. So we have a heartbeat messenger, which is not PG related. It is like a host level service. So we can leave them as it is now, right? Because if we need to make the heartbeat messenger to be across cores, it will be really different to manage those metadata in different cores, and we don't need
I
to
don't
do
see
that,
any need
right?
to do that. I think you pin it to a single core.
Yeah, I think we can leave them as it is now, right?
I mean, all of the PGs do need to update information in it, so you'll have to update it to permit updates from other reactors to its own in-memory state, but that's not a huge deal. You can do it by sending messages to the core. Not a biggie.
No, I mean heartbeat.
Yeah, I'm not talking about the messages. I mean, so what the heartbeat messenger actually does is it maintains a bunch of OSD-wide state, some of which are minimums and maximums of the PGs on that OSD. So all of the PGs, when they're doing their own thing, are updating state that the heartbeat messenger then condenses into a message that is the heartbeat, right? So there is information that will need to make its way from the other reactors to the heartbeat messenger, but I don't think that's not to the heartbeat messenger, to the heartbeat state. I'm sorry. Yeah, the heartbeat messenger would remain in one core. I see what you're getting at now. Yes.
Oh, yeah.
The OSD heartbeat state is what I was talking about. It's a separate thing.
Mm-hmm. Okay, a third question. How does those events, so like the connected event, the reset event, remote reset event, if we have migrate to M2N messenger? So
it depends on what
that part
they're
will be
actually
changed.
doing. Yeah, something needs to handle them. I see what you mean. What are these? For an OSD heartbeat failure or for an OSD connection failure, that's entirely messenger. Well, okay, so there's the parts of for stateful connections, all of the requeuing messages stuff still gets handled the same way. That's all inside of the messenger on whichever core it happened on. Trying to think, where do you actually get callbacks on connections? It's
Connection will call the dispatcher interface.
like client connections don't generate events, so those don't matter. For OSD information, when we get a reset, it triggers the behavior where we send a message to the monitor. So whatever handler exists for that probably just gets pinned to reactor 0 for now. I don't know. We'll have to look at that code in some more detail. My guess, however, is that for every connection, either it'll default to reactor 0 or the connection will get a tagged reactor where the callbacks will happen. Does that make sense?
I think so, but we need to look at each cases individually, right?
Yeah, I think the two big users are OSD liveness checking and watch notify. That's the other one I'd forgotten. So that'll be subsumed when we figure out how we want to deal with the watch notify state.
Yeah.
It has its own slightly complicated many-to-many mapping.
Yeah. So as the first step, so currently messenger is single core messenger. So can we assume it can be decoupled so that we can use that single core messenger to serve the multi-core OSD? So they can have different development pace.
Yeah, I think that's correct. Yes. I think messengers will in general be single core. So actually, I guess this is something to ask you about. If you're serving on a single port, is there any advantage in the messenger being able to run on multiple cores at all? Keeping in mind that the messenger is not doing any work, it's just handing off the message to the corresponding backing reactor.
The connection will be benefit because there are encode-decode works inside the connection. So if the connection itself is jotted among the cores, the work can be distributed to all the cores.
So you could have a multi-core reactor accepting on a single port, where each connection that comes in ends up local to a single core. That might be worthwhile. But even in that case, the core the connection ends up on won't necessarily have any relationship to the messages it's serving without the future work we haven't talked about yet. So in that case, you're still going to have to hand off the messages to whichever reactor they're supposed to go to. So my suggestion to you is that, indeed, we just let the messenger be one core for now and work on creating the multi-core infrastructure in the OSD first.
Yeah.
Hey, Sam, one question here. So still there's some information shared between the multi-cores, for example, configuration with map collection. So how we share the information? You just one call hold the data, and the other calls request the information?
Not necessarily. So we can do the same RCU trick I was describing before. Configuration information could be shared as a sort of widely available memory map, or we can investigate some other implementation if we need to. I'm open to suggestions on that, in other words. I don't think we want every config query to involve a remote message to another core. That would get expensive fast.
Yeah, at this moment, each core has its own copy of the configurations.
Yeah, so as long as we have a way of broadcasting updates, that seems fine. That would work great. As a result of a config change. So yeah, that seems perfectly adequate.
And when it comes to watch notify, I believe that this shouldn't be a problem. In Crimson, everything related to Crimson Watch Notify is actually encapsulated inside the boundaries of APG.
Except for the fact that the sessions that react to it actually interact with multiple PGs. Watch Notify is going to be a problem. Not like an unsolvable one, but one that will require actual architecture. If you want to have a preview of what it looks like, have a look at how Classic OSD does it. We're going to have essentially the same problem. Again, with hopefully better libraries and better readability, but the same basic problem. That is, so Watch Notify is dealing with connection state, right? But a single connection might have watches on objects from multiple PGs that are therefore on multiple reactors. For that reason, the state associated with the watches associated with a single connection can't be local to a particular reactor. That architecture will have to be somewhat more complicated. They'll probably have to belong to the messenger reactor, in fact. I don't want to get too far into this because honestly, I don't remember the interface well enough even to remember what the requirements are. But we're going to want to write some little boxes on Google Docs or something, so we're all satisfied with what it looks like. I think it's a project for a couple of months.
Yeah.
It's not a big problem. Again, Classic OSD already has pretty much the solution we want here. It's really a matter of translating it into libraries and primitives that are more convenient for Seastar. Watch Notify isn't a big performance intensive thing, so we don't even need to be
it's on cold path usually, so.
It's important that it not be inordinately expensive or silly, but yeah, it doesn't need this isn't something that happens in every I/O.
Hey, Sam, you mentioned that we will not have multiple OSD in a single process. Is that what you mean?
I don't think it's a good idea. I'm willing to argue about it, but we've been arguing about this for a year, and I still haven't heard a good reason to do it that way.
Okay, I thought we were going to discuss this over this meeting, but I was.
Well, we discussed it a bit before. So, at a core, the problem with having multiple OSDs in a single process is that if one of them crashes, they all crash. By the time you have multiple OSDs, you're already paying metadata overhead in a lot of places where it's very expensive. So at that point, you may as well run them in different processes. It's just cheaper.
Okay. Okay.
Like that's
I thought
the argument. Is there a counter argument?
in classical OSD for it also have a name like co-location OSD in the same host something.
No, sorry. You can have multiple OSDs in the same host. You said same process.
Yes, same process.
There is no way to do that with classic OSD currently. We permit it for testing sometimes, in that it's literally possible to create two OSD objects, but no, there's no way to configure classic OSD to run two OSDs.
Okay, I see now.
So to summarize, you're discussing going forward with M10 mapping, where the OSD operates much the same as it does with classical OSD, having essentially a single OSD instance per object store and per device.
Yeah. For deployment purposes, you could still choose to partition a device and create two of them. Like, same with classic OSD. But I think there are a couple of core questions. One, do we want to require use of multiple cores to require different processes? I would argue no, because we want the backing object store implementation to be able to share memory. If they're sharing memory, do we want to use multiple OSDs? The answer then is also no, because we've already paid a lot of the complexity, and the monitor would have to do a lot of extra metadata to support multiple OSDs. So that leaves us with this version, which is that an OSD runs multiple reactors. A subset of the reactors host messengers, a subset of the reactors host object stores, and a subset of the reactors host PG data. It's possible that in some configurations those three sets are identical. And when a messenger gets a message, it's always for the core that it already is on, which means it gets handed directly to the very same reactor, gets picked up by a PG on that reactor, work happens, and it gets passed directly through to the Seastore instance right behind it. In that configuration, unlike classic OSD, everything gets handled by the same thread. But architecturally, it would also support a situation where we don't want 128 Seastore instances. So instead, we have 128 messengers, 128 PGs, but only, 32 Seastore instances. Because for whatever reason, that's the more efficient way to do it. So we would be able to independently scale these things. Does that make sense?
Yeah, sort of. I thought we could in this way we could share the different resource which could be shared across different OSDs, but yes,
having multiple OSDs is bad. Like, that's not a good thing. So by the time we've chosen to go to the work of supporting multiple reactors, at least at the object store level, we also don't want multiple OSDs, because having multiple OSDs in the same process when they don't have independent failure domains means we're artificially imposing extra work on the monitors.
And our discussion here was whether this is actually a problem or not.
It's a problem.
I will just check the assumptions we made, and that's all. Still, I keep in mind the discussion we had.
What I'm saying is, it doesn't even save much complexity at that point. Like, we've already gone to the work of creating cross-core communication primitives to allow the multiple OSDs, in quote, to talk to the common object store backend. So we've already done that work. So why would we stop there? It doesn't seem sensible.
Okay, the reason could be actually to not worry at all about extending the protocol. Wouldn't be at all about passing messages across cores.
Passing messages is a special case of the general case of cross-core communication, which we're opting into here. In fact, passing messages is relatively easy.
I'm just arguing that in that scenario, the cross communication, the cross-core communication would be extremely limited just to the object store related crossbar. Actually,
it's no more complicated than the messenger one, or it's no less complicated than the messenger one. They're essentially the same thing.
Conceptually, yep, I can agree with that. At the level of implementation, it will be two different things.
Different, yes, but both complicated.
So in other words, we still need to worry about how to shard a given set of core to different OSD instances, right?
Yeah, I claim that that's not a big deal. So first off, this is Ceph ADM's problem, not Crimson OSD's or whatever.
Right.
Ceph ADM it could either statically configure which cores go to which OSD, which is fine with me, or it could be offloaded to the way that containers work. I think containers actually can limit the number of cores seen by a process. So maybe we don't need to worry about it at all. If we assume that Crimson OSD is containerized, then we could just assume that it owns whatever cores it sees. So done and done. So I'm not worried about that part. Go ahead.
And we can talk more about that part in the orchestrator session. I think that's tomorrow.
Worst case scenario. Oh, sorry.
Yeah, I don't think it's a big deal if like a Ceph ADM has to like pass in a list of cores to use, for example.
Yeah, it's just another configuration property along with everything else. It can be embedded in, like there's metadata even with classic OSD we like write down into the little BlueStore config folder. This can be one of those things. And it's soft state too, so it doesn't even need to be consistent boot to boot. No, I think the hard part is, as you guys have put your fingers on, there are a number of pieces of state, like the watch notify state, the OSD map state itself, this mapping from PGs to cores that are fundamentally cross-core pieces of state. We need to write code for all that stuff. We need to define the messenger to OSD interface that a messenger to OSD interface that appropriately deals with this localization of PG to reactor. And we need to test the hell out of it. Everything else, I think, is just wiring up configuration stuff, which is also a lot of work, but less conceptually tricky. And if we do want to defer this and we are happy with statically partitioning disks and running multiple OSDs, that's fine too. We should work on something else in that case and use what we already have if we want to defer this work till later. But I don't think we should do an intermediate thing. We should either start working on the final version or use this version for a while longer.
Yeah, from my perspective, I think it makes sense to start working on this sooner than later.
That's my perspective as well.
It's going to be like the essentially make it have the same deployment model as a classical OSD, which means that the integration with deployment tools is going to be quite a bit simpler. There's no reason to implement like a crazy deployment method that we're not going to throw away in 6 months.
I mean, it's not that crazy. I've seen people do that with classic OSD, particularly with really, really high throughput NVMe devices. You just statically partition up the disk and run one OSD each. Ceph ADM even probably supports it if you do the partitioning ahead of time and just give it the devices.
But still, what does it gain us to run things like that right now if we're going to go this direction in the future?
Oh, it doesn't. I'm saying as long as we support running Crimson OSD at all, we necessarily support this in the same way we support it for classic OSD, which is fine with me. I'm saying we would by default support it to the extent that we care to.
All right, well, this is great. It sounds like we've got several different independent projects that can proceed in parallel along this direction. So looks like the last thing here is Seastore.
Yeah, there's a link there to just some current state. Okay, so in the last year, the TLDR is we've got a transactional layer with a logical block indirection. And we've got an O-node index, an OMAP, and garbage collection, and a little tool for running FIO workloads against the lower level interfaces. We're just now wrapping up the work of wiring up the higher level interfaces so that we can actually run an OSD on it. We've got the OMAP portions wired up as well as the O-node stuff itself. I'm finishing up the extent stuff in the next week or two, and I believe Shuihan is working on XAdder and the metadata machinery, neither of which should be a huge deal. After that, it's mostly, there are two sort of big device integration stories to consider. One is that Seastore currently is designed for ZNS devices because that seemed like the primary design limiting use case. So I wanted to make sure the transaction internals were capable of dealing with it. But there are devices for which direct mutation of the storage is actually fine. So there's a document at the bottom detailing the initial ideas of how we're going to support that. But the short answer is we'll create an additional storage interface next to Segment Manager for directly mutable storage. And we will add an additional commit phase to the journal write portion, and extents will know whether they came from a ZNS-like device or a randomly mutable-like device on a per extent basis. So we'll be able to support both sorts of devices in the same Seastore instance if we choose to set it up so it can be configured that way. This should set us up nicely for future tiering-like work, where we tier between a smaller, faster device and a cheaper QLC device. The other major component is persistent memory, which Yingzhen has a document here for integrating into the cache itself. And the notion here will be that the currently ephemeral cache when there is persistent memory, we'll just have its extents located directly there. And we will journal enough state to reconstruct the mapping from those extents back to the physical addresses they're meant to represent, which should layer nicely on top of the other support. It also means we don't need to expressly cache things like metadata. They'll just be naturally cached as a consequence of caching the blocks they're contained in. It gives us a simple way of doing partial caching as well, based on usage. So all we have to do is
when we're storing these pieces of metadata in the same form, they're represented in memory, so there's no decoding.
So by cache here, I mean a block cache. So
yes.
If it's 4K blocks, it's just 4K extents. The thing that maps those extents back to where they came from is an ephemeral mapping that we will periodically dump into the journal with delta updates as we go through. So every time we put something into the cache, the transaction that represents it will also have a special delta updating the in-memory mapping, so that on reboot we can rebuild the mapping such as it was at crash time.
The question is more on the cache lookup side. So you're looking up an O-node. What does that involve?
The O-nodes are a B tree, so you descend the B tree, looking at each extent in turn. One presumes the upper levels of the B tree will be appropriately kept in cache, so those will be in-memory or persistent memory lookups. Eventually, you either fall out of cache or you find what you need.
Is this the same block cache you're talking about?
The very same block cache. The metadata for the O-node index itself are themselves blocks. It's just a B tree.
Okay. And just to be clear, there's no decoding of that state because it's the same on disk in those blocks.
Yeah. So you don't, for instance, need to pull the entire block, decode the whole thing into a standard map, and then
right.
You interpret the on-disk state to get to the appropriate buffer inside the block, and then you interpret the fields as needed to get to what you're trying to get to.
What I'm getting at, I guess, is that because there's no extra translation needed, that's why using a block cache for everything makes sense. Like in BlueStore, for example, there's a separate block caching layer versus a cache that is dedicated to things that were already decoded. Because of course, accessing things that are already decoded is much quicker but in this case, there's no extra step there, so it's not necessary.
Shouldn't be, no. I do not think deanc will show up at any point here.
Yeah.
Right now, all we have are actual direct integers and like unexpressed buffers. So that's clearly you don't decode those. The object info, presumably you still do because that's the OSD's problem, but that's a problem to be solved later. But the rest of the node, no. Like for instance, if you're trying to read out the extent information, what you'll read out is a couple of integers representing the logical address map or logical address range corresponding to the object's own range, and then you just directly look those up. You don't decode it. To the extent that those blobs exist at all, it's in the on-disk representation of the logical address mapping in its own B tree. It's not separately represented in the O node.
Right.
The logical address mapping, incidentally, can be sparse. So that's where the sparseness happens. It's there, not in the, there's no blob info equivalent for it.
Yeah, I guess maybe further in the future, might want to rethink the object info piece, but you said that's later.
Yeah, and it's part of it's that it's just expensive to run. Like the specific encoding we use is expensive.
Mm-hmm.
So there's that, and then wholly separately from that, we don't usually need the whole thing. So
yes.
Separating out portions of it so that we only need to access part of it would also work. Yeah, I'm ambivalent sort of about that. As long as the data itself is in line within the O node under reasonable conditions, which it will be here. Joyhan is going to inline up to reasonable sizes the object info and the snapset. I think that's about all the object store layer can do to help. We'll return a buffer pointer that will be the same buffer pointer that it was before. For persistent memory, we'll have to go to some
we could reconsider the layering a little bit, potentially.
We can, but there are buffer problems. So if we just let the OSD hang on to those buffers till the end of time, then it badly complicates things Seastore is able to do with memory. So as long as we keep the data bundle small enough, and we limit the actual cost of doing the decoding, then everything else isn't nearly as important. Like the main problem isn't that object infos are expensive to copy or that they're expensive to decode, it's that they're too big in the first place.
Yeah.
There's too much in them.
Yeah, that's certainly
if it were just a struct of numbers, we wouldn't even be having this conversation. You just copy the struct out of it and interpret the fields as you need it, probably without even doing the bit twiddling.
There's also the memory management aspect, but that's probably less of an issue with Seastar.
Yeah, and if it were small enough, you'd probably copy it by value.
Sure.
Like you wouldn't bother to heap allocate it. Or you'd stick it directly into a pre-allocated field within an op context structure that gets pooled.
Right. Yeah, certainly breaking it down into a smaller piece that could be fixed size or reasonably fixed size for the common case.
Yeah.
The kind of thing that we could look at in the future.
To answer the larger question, yeah, as this starts to become usable, messing with that, like we may want to move object info out of xadder and into its own special purpose thing with its own special purpose rules. If that's what we have to do to make it behave better, that's what we'll do.
Mm-hmm.
We might even be able to expose the O node object itself within Seastore, thanks to Yingzhen's work with the cursors in the B tree implementation. Permit keeping the actual memory extent associated with the offset for an O node. In memory and usable outside of that interface. So we could conceivably even expose that all the way up into the OSD, although with the set of caveats and wherefores there is substantial. But it's a thing we could consider.
Yeah, definitely a lot of room for optimizations in the future.
See what other Seastore things. Then there's just like a ton of performance work to be done. It's also a little bit crashy right now, as Chen Mei has been discovering. So debugging would also be good. There is essentially no way that any of the data structures I used in Transaction Manager are appropriate. So most of those will need to be profiled and replaced. We need a lot of work. Like, I've listed out a few things here that are obvious instrumentation gaps, but it's the tip of the iceberg. There's so much more that needs to be done there. The first step is probably to introduce some kind of instrumentation interface that we want to agree to use in that and in Crimson, and then start wiring it up. So if anyone's interested. So basically, many of these little subheadings are things pretty much anyone could work on. And Seastore has the benefit that it's a much smaller code base than Crimson as a whole. And right now, it literally can't run in Crimson. So you can only run this little tester, which is much less code than Crimson as a whole. So I would suggest that if anyone's interested in getting comfortable with Seastar and the Crimson
Sam,
project,
what do you mean by instrumentation? You mean something like event tracking?
I don't know. So for instance, I can just predict what I'm going to want to know in the next couple of months. I'm going to want to be able to know how many extents were mutated, how many extents were retired, how many extents were allocated, how many bytes were written, how many bytes were released. Because I want to track, for the bytes and release thing, it's because I want to be able to track the disk versus the number of bytes written versus number of logical bytes written. To track write amplification. We'll also want to be able to track usage amplification of the way the garbage collector is working, as well as performance indicators. So
I see.
lots of it's not any one thing. It's going to depend. I suspect we will want both event tracing with sampling of some sort and also aggregate stats. Aggregate stats are probably easier, so we should probably do that first.
Yeah, it's actually sounds like a combination of perf counter with event tracker.
Well, I mean, I don't. Two different things probably, but yeah. Yeah, I mean, like a perf counter-like implementation would do the job. So I don't remember if we have one of those in Crimson yet. We're probably getting to the point where that's a good idea.
We have.
Yeah.
It was added ported by TrimMate, but I wonder if we
cool.
could
Okay.
have a metric group offered by Seastar and have it integrated in our framework.
I believe it's already done. At least Avnum was working on that, on dumping the Seastar provided counters to the with the tooling we already have in OSD, admin comments.
Anyway, I know we're already over, so that's kind of where. That's I think a good summary of what the next steps for Seastore are.
Great, thanks. Yeah, sounds like there are a lot of pieces there that, like you said, could be tackled by somebody perhaps new to the project more easily. That could be a good starting point.
We've actually got some ZNS drives. I forgot to mention that, so that's another piece. I don't know. I anticipate that it may be annoying to access the ZNS library interfaces through Seastar, so that may be some amount of work. I hope to get a look at that. Anyway.
Okay, cool. I think that was the last thing on the agenda. Go ahead, Gifu.
I'm just out of curiosity. Are we supposed to access ZNS using some library for accessing it?
I think so. I don't know. I have quite a bit to learn there. We finally physically have some drives, so this is a thing I plan on tackling in the next week or two, or month or two. Depending.
Yeah, well, I'm wondering if we need to use some user space libraries for accessing it, and we need to integrate it into Seastar.
Yeah, I mean it can't be that hard. One assumes. I don't know. We'll see.
Could be more complex than Linux AIO, right?
The
Yeah, in that
implementation?
case, I also need to worry about it.
I don't know. What if it already has an IOU ring hook? That would be the easiest thing, except that Seastore doesn't support IOU ring yet.
Not yet, if I recall correctly, but there's a pending PR or pending
Oh, is
patch.
it alive again? Last I checked, it had gone dormant. Anyway, that's another thing we need to keep track of.
And another one quite similar to this would be about the user space drivers. Do we envision to tackle them in this cycle or postpone?
User space drivers for what?
DPDK / SPDK.
I prefer IOU ring to those things. Personally. From a strategy standpoint, it seems more likely to actually work for a long period of time.
I see. I'm not surprised. The kernel drivers looks like far more proliferated than any user space drivers. I'm asking because initially we had some requirements towards them, and I'm not sure about its current status. Do we need to still worry about DPDK, SPDK, about user space drivers in general?
I don't personally worry about that right now. That may
Yeah, I
change.
think it's too early to worry about it. I think we want to use what's available now and is simpler to use and get the basics of the OS of Crimson working first. And feature-wise, once it's complete, then we can start thinking about more optimal ways to do network and disk I/O.
Yeah, I think that's right. Until things just become available, what we have now is fine. It's not our goal, I think, or it's not an immediate need to transition to more efficient interfaces. But even when we do, it's more likely to be IOU ring than DPDK. So I sort of don't anticipate DPDK being a big deal.
Okay, but those things are actually very different. IOU ring is still about kernel provided stack.
IOU ring is an extremely thin wrapper around the NVMe drivers.
Exactly, it's not a replacement for DPDK. It's a replacement for the syscall interface.
No, they're both. No, it and DPDK are trying to do similar things. They're trying to make it so that when you're accessing certain kinds of underlying devices, you can do so with low latency and low overhead. They do it in wildly different ways, admittedly, and IOU ring does technically still involve the kernel. But it also allows the device to still behave properly for all of the other tooling, which is a pretty big deal. So I agree that they aren't the same thing. I don't agree that they're like unrelated. Anywho, mainly Josh's point is valid. This isn't actually the thing to worry about now.
Okay, fine with that.
Yeah, I think one of the most important things to focus on for this cycle is more about stability and increasing the test coverage, just like you've been doing, Radek, knocking down tons of bugs and expanding the tests that can run.
Well, still a lot to do. Anyway, just maybe 5 hours ago, the watch timeout has passed the unit test. So,
oh, nice.
Excellent.
Getting back to the tautology testing just after polishing the code, which I believe take maybe few hours, not more.
That's great. Yeah, looking forward to seeing if we can run more tests and find even further varieties of bugs.
Yeah, pretty sure there is a lot of them.
No, I guess snapshots are probably a goal for Quincy. That didn't make the list, but it should have.
Yeah. And Gavi will be able to work on the snapshots once he finishes up his current project of the Seastore allocation metadata. That's getting pretty close now.
I don't think there's a ton to say about snapshots. The semantics and underlying representations are pretty analogous to what classic OSD does.
Yeah, it should be a much more straightforward port than, for example, Scrub was.
Yes.
Thanks for coming, everybody.